Today we're going to be looking at absolute value inequalities. In doing so, the first thing we're going to look at is the directionality of the inequality itself. If it is open away from the absolute value, this is giving me an AND statement. If it's open towards, this is an OR statement. Now, the second thing we're going to do is we're going to set up the equation. In setting up the equation, we copy down all parts except for the absolute value symbols. So I would get 4x minus 2 is less than 10. And remember, with absolute value, there's going to be that positive representation or a value or the negative value. So again, I say 4x minus 2. When inputting the negative value, I'm going to flip the sign, then input my negative 10. Now, I'm going to use inverse operations to solve each one of these statements. In doing so, I'm going to get 4x is less than 12 and 4x is greater than negative 8. As I divide out my 4, I have x is less than 3 and x is greater than negative 2. And I simply just put those two as my interval notations. Those are my low values to my high values. Let's continue on with the second problem. Again, we're copying down exactly as written, just removing the absolute value. And then for the second one, we're going to include the negative into the 10, flip the sign, and where the absolute value was, it looks the same. We do inverse operations once more. In doing so, we have 6 is less than or equal to negative 2x, or negative 14 is greater or equal to negative 2x. Now we need to divide out the negative 2. In doing so, our sign is going to flip again. And we get negative 3 is greater or equal to x. And 7 is less than or equal to x. Now, because this is an OR statement, we're going to be looking at 2 points. Two intervals. So the first interval is a low point of negative infinity with a high point of negative 3, and there's a bracket around 3. For the second interval, it is a low point of 7 and a high point of infinity. Let's move on to problem number 3. Again, we simply just set the problem up, writing it as we see it, and then including the same kind of problem, but a negative value. So we flip the sign and it's negative 16. As we do our inverse operations, we should, again, end up with a value, or 2 values rather. So x is greater than 5, or x is less than negative 3.4. And now, again, we're just setting up as 2 intervals. So our low point here is 5, and our high point is infinity. Here, our low point is negative infinity, and our high point is negative 3.4. As we go into problem 4, we might notice that it's slightly different. So as we set up the first problem, we write it exactly as we see it. Then we go to set up the second problem and think, well, we can't really make 0, and negative. So we simply just flip the sign and put 0 again. As I'm doing my inverse operations, hopefully these are becoming easier and easier to do. But I'm left with x being simultaneously greater than -6 and x being less than -6. And I put those as my intervals. So it's greater than -6, meaning -6 is my low value and infinite is my high value. That intersects with my low value being -infinity and my high value being -6. I'm going to move now to problems 5 and 6. Copying down once again as they're written, setting it to the positive value, or setting it to the negative value. Solving with my inverse operations. I now get -3x is greater or equal to 6, and -3x is less than or equal to -10. I divide out by my -3. As I divide out by -3, my sign flips. So x is less than or equal to -2, or x is greater or equal to 10/3. I'm going to leave this as a fraction. I find it easier to leave these problems that way. If you did it on your calculator, though, you might end up with 3.3 repeating. So again, I make my interval. The low point is -infinity to my high point of -2. My low point here is 10/3 to my high point of positive infinity. And do notice, of course, that you have the brackets because those points are included. I continue on. 7x minus 5 is less than 7, and 7x minus 5 is greater than -7. Now, you might notice with some of these that as you're solving them, you're getting fractions, and that is okay. We can leave our answers as fractions, and it is not a sign that you have the wrong work. I'm going to divide, of course, out my 7. When I do that, I'm left with two fractions. I'm left with x is less than 12/7, and x is greater than -2/7. And this is an and statement. So this is giving me my low value of -2/7 and my high value of 12/7, my min and my max. Moving on to our last two problems. Are they an and or an or statement? Well, let's check. Which direction does it go to? It faces away from the absolute value, so that is an and that is also an and. So 28 is greater than or equal to 8x plus 4, and -28, flipping the sign, is less than or equal to 8x plus 4. I solve my equations with inverse operations. In doing so, I get 24 is greater or equal to 8x. I divide out my x. 3 is greater or equal to x. And on the other side, I divide out again by 8, not negative 8, excuse me, but 8, giving me negative 4 is less than or equal to x. Again, this is an and statement, so it's our low value to our high value. And now we're on to the very last one. Three x minus 7 is less than 13, and 3x minus 7 is greater than negative 13. As I add my 7, I get 3x being less than 20, and I get 3x being greater than negative 6. I divide out, and I have x as less than 320 over 3, and x as greater than negative 2. That is my minimum value to my maximum value. And that's it. Those are all of them.